Sandra, back with another SPSS video, and this one will be over probabilities with the t-table in SPSS. So previously we talked about probabilities with z-scores and how to find those in SPSS, and those are using the normal versions of CDF and IDF. But in this case, whenever we're working with the t-table, remember that this is when we are taking a random sample from the population and we do not know what the population standard deviation was. So they did not give us basically what sigma of the population is. So in this case, you have to use the t-table because you have a limited random sample and you also don't know much information about the overall population. So in this case, you are doing things with t statistics and the t-table. So how are we going to do that in SPSS? So there are two main concerns when we're talking about SPSS with regards to the t-table. So whenever the alpha and the degrees of freedom are given, or whenever the test statistic is given. So in most cases, they will ask you more for something like this, like the first example where we're trying to find what t-score or what t-value matches with an alpha of maybe 0.25, for example, and degrees of freedom of whatever. So most of the time, this is something that you'll be having to find in an exam setting. But of course, just in case, I also put just if the t statistic is given and not the actual probability. So first, we're going to do an example with this one. So when the alpha and the degrees of freedom are given, these are the steps that you need to take. So because alpha represents the probability of a t distribution, so when they ask us to find t of 0.025, given these degrees of freedom, in this case they've given us the probability, but we're trying to find the t statistic or the t value that matches this probability. So at what place in the t distribution is there a probability to the right of that t-score that is 0.025 given degrees of freedom equal to 36 in this example. So the computing of the variables, the process is very, very similar to how you would normally do it with probabilities given z-scores, just the settings are slightly different. So as you can see here, instead of IDF normal, we have to use IDF.t because this is with a t statistic. So in this case, let's try to do this in SPSS. So let's go to our data set. It doesn't really matter what data set you have because you're computing a variable. So you go to transform, you go to compute variable, and you don't use any of this. And we're also going to use a, let's just say, let's find the t-val. So what t-score matches with this question right here. So in this case, we have to go to inverse df still, but instead of having IDF normal, we have to go to IDF.t because we're working with a t distribution as it says here. So we double click on this and then you can plug in the relevant values. So here it says probability and degrees of freedom. So here the probability is 0.025 and the degrees of freedom are equal to 36. So this is exactly what we plug into our t numeric expression. So here we put 0.025 because that's our probability, and then here we put the degrees of freedom. So for us, the degrees of freedom is equal to 36, so that is what we put in here. So this is all you need for this type of numeric expression whenever you're trying to find the t-value that is associated with this probability and this degrees of freedom. So when you put this all into your SPSS, you click OK, and it will compute the variable for you. So then you need to just look in the SPSS table by scrolling all the way down, and here you see that it's negative 2.03. And this is completely fine. Since the t distribution is symmetrical, the negative t value is going to be the same as the positive. So the probability for this one, where t is 0.025 and the degrees of freedom are 36, if you get a negative 2.03, that's the same thing like saying a positive 2.03. Because again, the t distribution is symmetrical. So anything that is negative on one side is also the same exact value on the positive side. So in this case, totally fine that we have this. And all you would need to do whenever you are using this to maybe solve for a confidence interval is just take positive 2.03 as your t value. So don't worry about the negative too much because the distribution is always symmetrical. So a negative value is going to be the same exact value when positive. And if you want, again, a more specific decimal count rather than just to the hundredths place like it says here, you can always look above this number here at this like little bar, kind of, again, similar to Excel. And in this case, you see more numbers. So here you see 2.02809, etc. And obviously that will round to 0.03, but again, if the exam would ask you for something maybe a little bit more specific, or you're trying to use this t-value to calculate a confidence interval, maybe you want to go to maybe the 4th decimal place or the 5th decimal place in order to have the most accurate answer. So this is how you would find a t-value given the probability. And again, the probability that is given to us is 0.025 because the alpha represents the probability of a t-distribution. And if the opposite case was happening, so if the t-statistic was given, meaning that we know the t-value and we're trying to find the probability associated with that t-value, given a degrees of freedom, let's say of 36 again. So in this case, we would go to CDF and non-central CDF because we're trying to find the probability in this case and not the t-value like we would with inverse DF. And in this case, again, you have to use the CDF.t because we're dealing with the t-distribution, not a normal distribution, which would be associated with z-scores. So in this case, again, we are trying to find the probability that t is less than 1.4. So what we do is we go to transform, compute variable as always, and then let's say this time we're trying to find a t probability, so t prob. And instead of doing idf.t, we need to go back to CDF, and we need to scroll down until we find CDF-t. So again, this is talking about a t distribution, and we have quantity this time and degrees of freedom. So let's say now our quantity is 1.4, for example, and then our degrees of freedom, let's just keep it the same as the first example, so let's just keep it at 36. So given degrees of freedom of 36 and a t-value of 1.4, what is the probability associated with this t-value and this level of degrees of freedom? So if we click OK, it will execute this for us, and then we just find it here. So we see that the t-value that has a t-value of 1.4, the probability associated with that t-value is 0.91. So that means that basically the probability that t is less than 1.4 is 0.91. So that's how you would find a probability of within the t distribution given your t score or given a t-value. Normally the exam would more likely ask you about something like this because this is more relevant whenever you're trying to calculate a confidence interval. You don't know the t-value, but you know the probability, so you know alpha, and you know your degrees of freedom. So in this case, I would prioritize knowing how to calculate the t-value given the probability and given the degrees of freedom rather than the latter. But I wanted to show both just in case they do ask you, something like this, but it's not as likely as this top one. So both ways are good to know, but the process is pretty much the exact same as you would for a normal probability distribution. Just in this case, you have point t and point t for both of the examples, and you use IDF whenever you are given the alpha and given the degrees of freedom, because the alpha is the probability. So you're trying to find the t-value associated with that alpha. So that is going to be it for this video about the t-table in terms of SPSS. Stay tuned for the next 2 SPSS videos. One will be on confidence intervals, and one will be taking a smaller random sample from a larger SPSS dataset, meaning that if we have this workers 200 dataset with 200 participants in it, how do we take a random sample of 50 and then find maybe the mean or the variance with that smaller sample? So I will also be showing that in an SPSS video coming soon. But I hope, again, this was helpful for y'all. And yeah, I will see you guys in the next video. Bye.